Hey, welcome to CZVERSE. AI, crypto, quantum, robotics. I cover the technologies that are actually reshaping the world, and I try to explain them in a way that's honest and useful. Let's get into today's story. There is a massive physical bottleneck in quantum computing right now. Almost nobody outside the field talks about it, but it is one of the biggest practical obstacles keeping quantum computers from being genuinely useful. It's called calibration. Every quantum computer has to be continuously tuned because qubits, the basic units of computation, are incredibly fragile. A temperature shift of a millikelvin, minor electromagnetic interference, or even mechanical vibrations from a nearby air conditioning unit can cause these qubits to drift completely out of alignment. A quantum computer is effectively a useless machine unless it is meticulously and continuously forced back into a perfect physical state. Right now, getting a quantum processor into a state where it can run reliable computations requires highly specialized human experts. They spend days methodically measuring and adjusting thousands of individual parameters by hand. Look at the actual hardware these experts are tuning. The inside of a dilution refrigerator is a labyrinth of intricate, layered wiring and delicate golden architecture. Every single connection has to be perfectly dialed in. This animated chart illustrates why this manual process is hitting a wall. Calibrating a 50-qubit system is a small, manageable bar, but when scaling up to 1,000 qubits, complex interactions multiply. The human calibration time skyrockets vertically off the chart. The entire quantum computing industry cannot advance to the era of large, practical machines as long as humans are the ones turning the dials. This week, NVIDIA quietly released a solution to this exact problem. It's called Ising. Ising is an open-source collection of machine learning models. NVIDIA trained these models on vast amounts of data pulled from real, functioning quantum processors to help them understand exactly how quantum systems behave. Instead of humans guessing, the AI takes over. You feed it the current state of a quantum system, and the neural network predicts the precise tuning parameters for every individual qubit autonomously. What previously took days of exhausting trial and error now happens in hours. Artificial intelligence is now actively managing the physics of quantum computers. The speed limit for all subsequent research has officially been raised. The immediate impact across the ecosystem is a massive spike in research velocity. University labs and hardware startups no longer have to burn a week of lab time just setting up an experiment. They can run tests daily. NVIDIA amplified this speed by integrating Ising directly into the existing electronic design workflows that the industry already uses. By partnering with companies like Cadence, labs don't have to rebuild their entire software infrastructure to use the AI. We are watching a real-time technological convergence. We are using classical AI models to stabilize quantum hardware, so future quantum computers provide the compute for AI models that silicon simply can't process. The most influential organizations of the 2030s are those positioning themselves at the specific intersection of high-scale AI and quantum hardware. Which brings us to the strategic side of this release. Why did NVIDIA choose to make a tool this powerful completely open source and free to the public? It is a highly calculated move. NVIDIA is giving away the cure to the calibration bottleneck in order to build an industry-wide dependency on their underlying frameworks. This diagram illustrates the strategy. It's the exact same playbook they use to dominate AI. By providing the open-source Ising tools in the middle layer, they ensure that every major quantum hardware platform built on top of it runs smoothly. But that middle layer locks directly into the foundational layer, which relies entirely on NVIDIA's own massive GPU compute infrastructure. By providing a solution to this core physics hurdle, NVIDIA is methodically positioning itself as a mandatory infrastructure layer for the entire quantum era. This timeline projects the exact rollout. By 2027, AI calibration becomes the standard. Operating without NVIDIA mimics writing software without an OS. By 2030, as hardware scales to thousands of qubits, this embedded position translates into a major revenue and strategic advantage. The future of computing rarely arrives with a massive consumer product launch. Usually, it arrives quietly, hidden inside a highly technical calibration update. Thank you for watching. Seriously, I appreciate you being here. If this was helpful, hit like and subscribe so you don't miss the next one. Leave a comment with your take. Is NVIDIA's open source strategy a net positive for the quantum ecosystem, or does it risk creating a monopoly in a field that should stay open? Next video is Meta paying 3 billion users in USDC and Polygon becoming mainstream payments infrastructure overnight. See you there.